Hello everyone, welcome to this webinar on Oracle Coherence. My name is Mike Croft. I will be ably assisted in this webinar by my colleague Arvind and Anandam. And we're just going to take you through a little bit about getting started with Oracle Coherence. It's going to be very much an introduction to Coherence. We do have a further webinar which is going to go into a little bit more depth, talk about distributed execution and a few more advanced topics. So that's coming up, and we've got a slide to give you more details about that at the end. So just to recap, last week Steve did a webinar on what a data grid is and what it's not. He also went through quite a few key concepts about data grids, some of the ideas behind them, the way they work, and also mentioned some of the things that Coherence uses. So in today's webinar, we're going to look at Coherence itself. We're going to have a look at the way that works, how you configure a cache, how you cluster different nodes together to distribute the cache across those nodes, and how to interact with the cache programmatically with Java. So firstly, we're going to look at just a bit of an overview of Coherence. So to start with, the installation of Coherence is just a zip distribution, which you can get from the Oracle website. It's a free download for developer use. Obviously, if you want to look at using it in your organization, there is cost involved with licensing from Oracle. But when you download it, you'll find it's just a zip file with 3 directories: bin, lib, and doc. Bin contains a few shell scripts and Windows command files. Lib contains all the jar files, all the things that make Coherence work, and a bit of documentation as well. Now, Coherence does support distributed execution of code, as I mentioned earlier, but that's something more advanced that we're going to go into next week. Another thing that it supports is POF serialization. This is something that Oracle have introduced, and it's an alternative to the standard Java serialization, which is traditionally quite slow and limited to just the Java language. The way serialization works in Coherence, it can work over multiple different languages, and it can work over multiple different versions of the same object. So it's very flexible and quicker than the standard Java serialization methods. And it does obviously incur less overhead in terms of network usage, because serializing data obviously does reduce the size of the files that are being transferred over the network. Very important when you're talking about data grids. And lastly, Coherence is configured with XML files, and we're going to be looking at a few of those XML files in the next slides and how they work. So this is a sample XML file to configure a cache, and I'll just take you through a few of the main sections of this. The opening tag is the cache config tag. Those XSD files are necessary. But underneath that, we've got the cache scheme mapping. Now in there, we name the caches that we want to use. So in my example, I've got my cache, and the scheme name is distributed. So underneath the cache scheme mapping section, we've got caching schemes section, and we've got one distributed scheme, just referred to as distributed. Now, in this cache config file, you can have multiple different caching schemes, and you can also have multiple different cache mappings, which means that on any data grid that you want to create, and in any cluster, you can have multiple caches existing and working simultaneously, and you can also have quite a good level of control over the caching scheme for each of the caches. So in this one, we've got a distributed caching scheme, There are a couple of other different sorts that you can have, which Steve mentioned last week. The first that I want to talk about is replicated. So a replicated caching scheme is optimized for performance. Now that is where every single node in the cluster has a copy of the data. Now this does mean that update methods, so synchronous writes, do become very expensive as the number of machines in that cluster scales upwards. Obviously every single update needs to be replicated to every single member of the cluster. So the amount of writes that you're going to incur for every update is the same as the number of members in that cluster. Now this does have an advantage because you get much quicker read access because any node that you access has a local copy of all the data. Coherence by default is a distributed, or as Steve referred to it last week, a partitioned cache. This is where the data is separated into multiple partitions, which are then distributed across all members of the cluster. And this is, as opposed to replicated, is optimized for extreme scalability. So maybe not quite as performant, but it does scale much better. And the reason for that is that the number of synchronous writes that you make for every update is once for the primary copy of the data, and then once for every backup of that data that you have. So in a partition scheme, you will have one primary copy of the data and at least one backup, but you can configure that in Coherence to be as many as you want, depending on how valuable and how highly available you want your data to be. Now, this does have a disadvantage, which means that repartitioning the data or moving partitions around when a node fails or is brought down deliberately is quite expensive as the amount of data in the cache increases. And there is a third part of a third method of caching which Coherence supports, which is called optimistic. Now this is also known as a near cache, whereby the cluster uses a distributed cache as well as a local cache. So every time a piece of data gets retrieved from the cache, which isn't on the node you're connected to, that data is then cached locally so that next time there is no network hop to go and fetch that data again. And the way that Coherence decides what is kept in the local cache is the most recently accessed data and also the most frequently accessed data. So with the optimistic level of caching, or the optimistic caching scheme, what you get is both scalability and performance. And obviously all these are changed in the cache configuration that you can see here. So now what we're going to do is give you a little demo of Coherence. So we've got a putty window up here. This is connected to an EC2 instance on which I've got a installation. So now we're going to start up a cache server. Which you should see just starting up here. Now what I'm going to do before I do anything with that, I'm going to show you the settings and configurations of this. So first we'll look at the cache configuration, which is the same as the XML file that I just showed you. And here you can see that the cache name is EC2-cache. It's on a distributed scheme, and here are the settings for the distributed scheme, and you can see that the auto start is set to true. Okay, so now we've got this cache server started. This is a storage enabled node. You can also have storage disabled nodes with Coherence. And what we're going to do is set up a storage disabled node on this other window. And on here you can see that I've got this interface here. We've got map and question mark in a bracket. Now this is ready and waiting for me to join a cache. So because of the cache that I've got named in the XML file, I can type in the command cache ec2-cache, and I'll join the cache that I've specified in the ec2cache.xml. We can see here, and we can see that this is the configuration of it. Now I've got my colleague, as I mentioned, Arvind, sitting right next to me, and he's going to join the cache as well, and he's going to join with a storage enabled node. So if we can see in this first window that I've got open, we can see that we've got a number of different partitions, up to 128, which have been transferred over to him. So all the data in those partitions, or the data that would be in those partitions if we put any data in yet, will be transferred over to him, and this storage enabled node that we can see here would keep the other half. So all of the data that we input will have one main copy in the window that you can see here, and his copy will have all of the backups. Now that's obviously not exactly true. Some of the primaries will be on my machine and some of the primaries will be on his machine. But as far as Coherence is concerned, and as far as a user of Coherence is concerned, all that is transparent. So let's add some data. What I'm going to do is put some data. I'm going to put a message with a key of message and a value of hello Arvind. And now you can see that it's returned null, and there's a very good reason for that I'll get onto later. So if Arvind checks that message and maybe wants to put his own message, we've seen now there's another member that's joined, and now that member is Arvind's storage disabled node, which has his interface on it. So hopefully he should be sending us a message back very shortly. Now that's an interesting quirk of this interface. You can see this said unknown command get. Now the reason for that is because I typed in get up here just before Arvind joined the cluster. And then all of this got printed out. Now that actually has taken all of the input that I've written down there, all as one string there. So if we just try that again, this time it will work, and it says hello Mike. Okay, so that was just a quick demo of just putting some data in the cache. Arvind put some data in as well remotely, and we can all see the same data. So now I'm going to just talk a little bit about the cluster that we've created there with myself and Arvind. These are just a list of the things that can be configured with clustering in Coherence. So the first thing is cluster name. Now that is configured in a Tangasol configuration XML file, which is separate to the XML file that I've just shown you. You can also configure the member identity, which I've got a slide talking about in a moment. And now that is used to set unique member characteristics and parameters, which are useful for monitoring purposes. So if you wanted to monitor your cluster, you could see all of your nodes, see how they're behaving, see the health of those nodes. And with these member identity parameters, you can set descriptive strings that are going to let you know with quite a high level of granularity exactly which node on which machine in which server rack on which location in your data centers this node is. Multicast and unicast communication, that's obviously for clustering. Some networks obviously don't allow multicast, so you can use unicast instead. Multicast does need to be explicitly turned off, but it does use a TCMP communication protocol for heartbeats and for discovery. You can run Coherence in single server mode, so any cache that you create, you can say that I want that to be just on a single server, and it won't be available on any of the other servers in the cluster. It has death detection, which is quite highly configurable, which uses heartbeat intervals, as I mentioned, to see if a node is up and running or not. And now that's in TCP ring settings. You can configure the amount of attempts and the length of timeout of attempts to connect for these heartbeats. Now the default is 3 attempts and a timeout of 5 seconds each for those. Lastly, we've got priority. Now you can make one cluster member either a higher or lower priority than other members, depending on your use cases. So here's an example of the Tangasol configuration file I mentioned earlier. There's a lot in the file, so I've made some of it smaller, but we've got the important stuff made in bold. Now this is the XML file that we're using on the servers that you've just seen. So you can see that we've got a cluster name of EC2 cluster because we're running on Amazon EC2, and because Amazon EC2, like most cloud providers, doesn't support UDP multicast, we are using well-known address unicast for communication. So this address here is the address of the server you've just seen me interacting with on that port. And down here we've got the ec2-cache.xml. Now that's the description of all of the caches that are available to this cluster. So when you connect to this cluster, you can connect to any of the caches that are listed in that XML file. If you have a different cluster configured with a different cache configuration, you can't connect across those configurations. Now what I should say as well with this sort of clustering, the first member to connect and to initiate the cluster is known as the senior member. Now the senior member is just the oldest member of the cluster, and any time that the senior member leaves or goes down or fails, the next oldest then becomes the senior member and stays the senior member even if the original comes back up. And here lastly is the member identity configuration that I mentioned earlier. Now this is quite important with the level of granularity that you can have for monitoring. You can see there are system properties for site name, rack, machine, process, all the way down to member and role. Now each of these are fairly loose definitions. It's up to you how you want to use those, but the system properties obviously are named there as guidelines to how you want to use them. So let's dive back into our cluster here, and we're going to show you a little bit more about clustering and some of the other capabilities of Coherence. So firstly what we're going to do is add some more storage enabled nodes. So there's another one that's joined, and 43 partitions have been sent to that. And now if Arvind wants to join with another cluster member, then we'll see, once he's done that, another selection of partitions moving over to his new node. And there they go. So now each of the storage enabled nodes that we've got have got some of the data. There is going to be one primary copy of all the data and one backup copy of all the data, because that's the default in Coherence, and we haven't changed that. Now we can see all the members of the cluster by typing in cluster here, and we can see we've got a member ID of 1, 3, 4, 5, 6, and 7, and we can see that the IP address of this that I'm connected to at the moment is 10.34.212.6, which is member ID 1. We can see our storage enabled node on the right there. Member of ID 3 here is also on the machine that I'm connected to. We've got 2 here from Arvind, another one from me that I've just created, a storage enabled node, and a third one from Arvind there. So what I'm going to do is add in a bit of data. I'm going to put 1 mic. Now that's putting the value mic into the key 1. And you can see again it's returned null there. I'll get onto that in just a moment. So if I put 2 Arvind, let's put null again. Now if I was to update one of those, so for example 1, I decided that I didn't want to be in there, and I wanted to put Dave into 1, we can see that instead of outputting null, it outputs Mike. Now that's because Mike was the last value in 1. So when it returns null, that means that that value has not been initialized yet, and putting that data in has just created it in the cache. So now if we wanted to look at the data that we've got in the cache, we can just type list, and we've got our message that Arvind updated to say hello Mike, and we've got the 2 pieces of information that I've just added. Now what we can see is the high availability of Coherence. I've got my original storage enabled node here on the right. I'm going to kill that now, and we can see immediately in this node here, member 1 left service management with senior member 3, which is, as we can see up here after typing cluster, that's this member. So now if we type cluster, we can see that we've got down here in the recycle set, we've got member ID 1. So now if Arvind starts killing some servers, okay, there's another one gone. What I'll do is just join the cache again. So we've got caches dying everywhere, and we can see that here we've got partitions being redistributed dynamically as all this happens. It all happens automatically without any configuration from us. Let's just check the state of our cluster now. Then we've got member IDs 1, 6 and 7 which are recycled, and this member ID equals 3 is still active. Member ID equals 2, 3, 4 and 5 in our cluster. If we list the data, we can see that all of the data that we put in is still there. None of it got lost. And all of the data gets rebalanced around automatically each time a node comes up or leaves. Now what I'm going to do next is, Arvind, have you still got a data node up and running? Okay, so Arvind still has a storage node up and running. So what I'm going to do is kill this storage node, and I'm going to demonstrate querying. This is one of the interesting features of coherence on the command line and in Java. You can see we've got a different prompt here, COHQL for Coherence Query Language. And to start off with, we're going to select the right cache. Now there is a different format here that I'm using to connect to things. It's because it is a query language. I think it is extended from SQL. There we go, and we've joined our cluster. So now what I can do is select everything from EC2 cache, and we've got the results here. Now you can see that we've only got the values here, we haven't got the keys, but what we can also do is insert statements. And it is case sensitive before I make that mistake. Okay. And we should see, there I am, back in the list. And once more listing the values in the cache, there I am. So those are just different ways to interact with coherence, both equally valid. But if you prefer a query language, you want the power of a NoSQL style query, it's there and available for you in coherence. So next I'm just going to briefly talk about interacting with the cache programmatically. You can see here there's a screenshot of directory structure in a web application that I've had. Now I've got this XML file, mycacheconfig.xml, and that is exactly the same as the cache config that I showed you earlier, and the one that describes all the caches that we were using on EC2. And if I was to use the same configurations locally as I was on EC2, it would join exactly the same cache, and I could interact with exactly the same data. Now in code, here is a brief example. We've got our cache factory .ensure cluster. That line is entirely optional. And the reason why it is there is the cache is actually initialized lazily. So when you do cache factory.getCache mycache, that's going to incur a little bit of performance overhead because it doesn't initialize until you actually want the data. So doing ensure cluster to start with forces it to initialize, so you do get a performance gain there. Next we've got the get cache that just simply joins the cache that you want out of the cache config that you've included. And here's just a demonstration of doing a simple cache.put of a key and a value, and then printing out the value of that key to the command line. Now obviously it is important to shut down your cache factories once you're finished with them as well. One other important feature is the cache listener, which is a great feature of Coherence, whereby you can add a map listener to your cache, and there are these three events that you can override: entry updated, inserted, and deleted. So every time an entry gets created, an entry inserted event will be fired, and you can write some code to manage that and to handle that and do some sort of processing. So that has been a very brief overview of some of the things that you can do in Coherence. Just in summary, we've seen how you can configure and join a cache with the XML files and the different configs that you can have. We've seen how you can cluster multiple nodes together and how they are all highly available. You can join and kill members in the cluster as freely as you want, and it is very resilient. It can cope with all of those. And you can use a query language to interact with the cache. Now next time we'll be going into a little bit more depth. We'll be looking at distributed execution with Coherence. That's on Tuesday, June the 18th, so do mark that down in your diaries. But you can also connect with us on Twitter and on YouTube. You'll see this webinar will be uploaded to YouTube very shortly. We're also on Facebook and LinkedIn. And on our website you'll get details of how you can register for any future webinars that you want to find out from us. So thank you very much for listening.